So when we graph sine and cosine, technically your graphs would keep going forever because you could just keep going around your circle as many times as you wanted, right? We can do 5 pi or 7 pi or whatever just by keep going around. We will graph a period. So we will graph ours from 0 to 2 pi to get one complete cycle of what our graph looks like. So let's figure out what the graph of sine looks like. So we can make sure we're looking after this. Technically, a graph is found just by plotting ordered pairs. And we know all of these values for sine. So we could plot every single value that we've done so far. 0, pi over 6, pi over 4, pi over 3, pi over 2. We could do all of those. We are going to simplify it a bit and just plot the main ones. So we are going to look at 0, pi over 2, pi, 3 pi over 2, and 2 pi. What are those angles? If you think about it on your circle, where do those fall? The x and y axis. We're just doing every 90 degrees. Okay, what is the sine of 0? 0. What is the sine of pi over 2, or sine of 90? 1. What about at pi? 0. 3 pi over 2? -1. And 2 pi is 0. Okay, so on my graph, my high point here is 1, my low is -1. And I'm going to, these points on my x-axis are my angles. My pi over 2, pi, 3 pi over 2, and 2 pi. So then we just plot these. We're at 0, 0. Put in pi over 2, we get out 1. Pi, we got 0. 3 pi over 2 is -1. And 2 pi is 0. If I had made you plot the rest of the points, like your pi over 6, pi over 4, pi over 3, when we plotted those, we would see this is curved. These aren't straight lines. It's not like a zigzag. It's a nice, smooth curve. And so that's the graph of sine. Technically, I graphed it from 0 to 2 pi, but it would keep repeating if you chose to. You don't necessarily have to draw that on your handout, but just be aware, it doesn't just start at 0 and end at 2 pi. It's just, that's the pattern, and then it would just continue that pattern forever. So let's graph cosine. I'm going to graph this, and then I want to talk about domain and range for both of them. What's the cosine of 0? 1. At pi over 2, cosine is 0. At pi? 3 pi over 2? And 2 pi? Back to 1. So your angles are your x-axis points. So then we plot 0, 1, pi over 2, 0, and continue our pattern. So if we graph this, again, if we put more points, we would see this, but it is a nice curve. And we're starting at 0 and ending at 2 pi, but if you did continue it, it just keeps following the same pattern. It does the same thing over and over again. So it looks a lot like the sine, except it started at 1 and sine started at 0. Let's do domain and range for each of these. For sine, my domain is my x. If it keeps going, what's my domain here? Negative infinity to positive infinity. I only graphed 0 to 2 pi, but it'll keep going. My range, what y's do we hit? Negative 1 to positive 1. We do hit those values, so they get brackets. Okay. For cosine, what's your domain? Same thing, keeps going, and the range would also be negative 1 to 1, because those are the high and low points. Any questions about this? So now we're just back to our notebooks. We're just going to spend the rest of the day working on these two functions and talking about them. I do have a question. We have talked in college algebra, we talked about what it means to be even and odd. We said even meant it was symmetric to the y-axis, odd was symmetric to the origin. It's been a little while since we've done that. If you look at your graph of sine that you've plotted, is that one symmetric to the y-axis? If you fold it on the y-axis, does it overlap itself? Sine does? So this is what sine would look like. We graphed this part. If I went the other way, it would just keep following the pattern. If I fold that thing on the y-axis, does it overlap itself? No. If I fold it on the origin, so over the y and then the x, would it overlap? Yeah, if you fold it just over the y, it would look like this. And then if you fold it over the x, it would overlap itself. So, sine is symmetric to the origin, which means it is odd. What is really important, the definition of odd means if you have a negative on your angle, it's like having the opposite of what you started with. This is the property that we're going to use from that. We'll graph transformations of these. And since sine is odd, anytime there's a negative on the angle, we'll just pull it out in front. Okay. If you think about cosine, so we graph cosine from 0 to 2 pi. If I did the other direction, it would look like this. Is that even or odd? Even. That one is symmetric to the y-axis, right? If I fold it on the y-axis, those sides overlap itself. So, cosine is symmetric to the y-axis, which means it is even. Now what we are really getting at there is if you have the cosine of a negative angle, it is the exact same thing as the cosine of the positive. So because cosine is even, if we have a negative on the angle, we are able to just drop it off. Those two things are going to be extremely useful to us. Questions there? So I want to start graphing some variations of these. Let's graph sine of 2, or excuse me, 2 sine of x. What I expect from you on your graph. Your x-axis, I want you to put, it's really 5 points. We're starting at 0, and then we have our pi over 2, pi, 3 pi over 2, and 2 pi, just like if you're going around the unit circle, those x and y axis points. Please try to space them evenly. I'm not taking a ruler and measuring that they're the exact same space apart, but it is going to skew your graphs, and if we get to the test and you aren't spacing those evenly, you are going to lose points there. Bless you. Okay, let's see what happens here. If I plugged in a 0, sine of 0 is, so 2 times 0 would still be 0. If I put in pi over 2, sine of pi over 2 is 1, right? If you just think about going around your circle. I'm just looking at these points. Sine is the y. So at pi over 2, my sine is 1. But then if I take that times 2, 1 times 2 would give me a 2. So at pi over 2, we're getting out 2 for the equation we're graphing. Sine of pi, at pi my y is 0, so 2 times 0 is 0. At 3 pi over 2, sine is negative 1, so 2 times negative 1 is negative 2. And at 2 pi, you're back to 0, times 2 is 0. Now when you graph it, make sure it is curved. I don't want corners or anything like that. So it looks something like this. I asked you to compare that to the graph of sine. The sine that we graphed before was exactly like this, except at pi over 2 and 3 pi over 2, our y values were 1. So what did that 2 in front do? It's like a vertical stretch, right? Isn't that the same transformations we talked about in college algebra and algebra 2? If you have a number out in front, it's like multiplying your y's by those numbers. So a number in front is going to stretch this. In terms of trig functions, that number has a special name. We call that the amplitude of the graph. What would happen if I put a 1/2 in front? It would shrink it, right? Okay, so what you want to write down, the amplitude of a periodic function. It's defined as half the distance between the maximum and minimum values. In other words, the graph we just had went from -2 to +2. So that's a distance of 4. Half of that is 2. For right now, you can think of amplitude as your high and low points. So if the amplitude is 2, you're going to have a high point of 2 and a low point of -2. If our amplitude would be 3, we'd have a high point of 3 and a low point -3. One thing to note, the amplitude is always positive. Okay, so if it were a -2 in front, we don't say the amplitude is -2. The amplitude is still 2. What would a negative in front of our graph do? Flips it over the x-axis. Any questions there? Let's graph this one and see what happens. So y equals the sine of 2x. on your x-axis. 0, pi over 2, pi, 3 pi over 2, and 2 pi. If I plug in a 0 to this, 2 times 0 is 0, sine of 0 is 0. If I put in pi over 2, 2 times pi over 2 is pi, and sine of pi is 0. If I put in a pi, 2 times pi is pi, sine of 2 pi is 0. Does everybody understand where I'm getting these points? Okay. I'm taking these x's and plugging them in right here. So like the first one I did sine pi over 2 times. I got sine of pi, which from our unit circle we know is 0. Okay, so if I wanted 3 pi over 2, so that's sine of 2 times 3 pi over 2. So that's the sine of 3 pi. So we know you're at 0, pi, 2 pi. So 3 pi would be back here, and sine is 0. If I put in a 2 pi, sine of 2 times 2 pi is sine of 4 pi. And 4 pi is back here, and it's 0. So does that mean this graph is always 0? Probably not. What do we need to do? Okay, let's try some points in between here. Think about your unit circle. Pi over 2 is like 90. What's halfway in between 0 and 90? Pi over 4. Okay, so we would do the pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Let's try those. If I plug in a pi over 4, 2 times pi over 4 is pi over 2. Sine of pi over 2 is 1. Okay, if I put in 3 pi over 4, 2 times 3 pi over 4 is 3 pi over 2. Sine is negative 1. I did 5 pi over 4. 5 pi over 4 times 2 is 5 pi over 2. So here's pi over 2, 3 pi over 2. So 5 pi over 2 would be back up here, which is 1. If I put in 7 pi over 4 times 2, that's 7 pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2. 7 pi over 2 is back down there, which is negative 1. If I graph this, what has happened to my graph? How many cycles of sine did I graph right there? 2, didn't I? This was the first one, and then after that it just repeated itself again. So I really have 2, call those periods, 2 periods of sine right there. That 2x took your graph and shrunk it, which is what we talked about when we did transformations. We said things attached to the x do the opposite of what we think. So multiplying your x's by 2 is like, if you have a 2 attached to your x, it's actually like dividing all those by 2, and it shrinks it in. Now, that's kind of sometimes hard to think about in terms of our trig functions. So even though this is all related to the transformations we've already done, we are going to use some different terms to do that. What that number actually changes is the period of the graph. It changes the time it takes for the graph to repeat. So if you have a number multiplied with your x, that will change your period. And what you need to know is the period of what the equation we are graphing is 2 pi, which is the normal period, how long it normally takes to repeat, divided by whatever number is there. So now we actually have the tools that we need to start graphing all these trig functions a little more quickly without actually having to plug in everything. When I give you a trig function, we are going to go through it, and the first things I'm going to have you write down are the amplitude of the graph, which we know amplitude is the number in front. Then we're going to do the period, which is 2 pi divided by the number in front of x. Okay, then I'm going to add in a count by, which I'll show you what I mean by that in a second, and then we will use those things to quickly sketch our graph. And then we don't actually have to take the time to make a t-chart and plug them in. Does everybody have that down? So now we're going to just start graphing these things. To graph this over 2 periods. First thing I want you to do is list the amplitude. The amplitude is always positive, and it's the coefficient in front. So what's my amplitude here? 2. Because there is a negative, what does that tell me is going to happen? Flips. So I'm going to just make myself a little note that I have to flip this one. It'll flip over the x-axis. The next thing we do is the period. Period is always 2 pi, because that's the normal period, divided by the number in front of x. So 2 pi over 3. That means if I start my graph at 0, when I get to 2 pi over 3, I will have the complete graph of sine in that amount of time. Now, we always want to do our 5 main points. Normally, that's the x and y axis points. But because I've changed the period, those points where I hit my 1 and -1 are going to change. So the next thing I want you to do is a count by. To count by, I am going to take my period, the length of time, and I'm going to divide it by 4 for the 4 quadrants on our unit circle. And that will always be the case. So count by is just your period divided by 4. If you need to use a calculator, you're welcome to do so. Just don't put in the pi's. Or you can think of it as times 1 over 4. So we should get what? Pi over 6. That is actually all I'm going to need to draw my graph. My amplitude is 2. That means the high point on my graph will be at +2, and the low point will be at -2. We want 5 points on the x-axis. We're starting at 0. And then we're going to have 4 points after that. Okay. To find those points, we're just going to use our count by. So the count by is like what you add to get the next point. So 0 plus pi over 6 is pi over 6. Pi over 6 plus pi over 6 would be 2 pi over 6, or pi over 3. 2 pi over 6 plus pi over 6 is 3 pi over 6, which is pi over 2. 3 pi over 6 plus pi over 6 is 4 pi over 6, which is 2 pi over 3. And notice we've seen that 2 pi over 3 before. We said that was our period. We said that's how long it would take to repeat. So it should work out that way. If you struggle with adding those things, you can use your calculator. You know, don't put in the pi's, but 1/6 plus 1/6 is 1/3. Plus 1/6 is a half. Plus 1/6 is 2/3. So you can get it that way. Now we're just going to follow our pattern for sine. We're looking at sine. If you look at your little handout, sine always starts at 0. Okay, then it goes up to its amplitude. But what am I doing on this graph? Flipping it. So instead of going up, I'm going to go down to -2. Now we're just going back and forth. So now we're going back up to 0, then we'll go up to +2, back down to 0. If you wanted to check yourself, you could. If you plug pi over 6 into this equation, you will get out -2. If you plug in your pi over 3, you do get out 0. We're just using the pattern of sine to do it faster than actually plugging those in. So at that point, you just draw your nice curve. And we have a period of sine here. Now, what did I say in the directions? 2 periods. So if I want 2 periods, what do you think I need to do? Keep going, right? How many additional points would I need? This is my first point, so I need 4 more after that. So if I ask for 2 periods, you just tack 4 more points on. We're just going to keep adding our count by for those. So 2 pi over 3 plus pi over 6 is 5 pi over 6. Plus pi over 6 is pi. Plus pi over 6 is 7 pi over 6. Plus pi over 6 would be 8 pi over 6, which is 4 pi over 3. And then we'll just continue the pattern. Where's my graph going to go from here? Down, my low point, and then back up. So add those points. So 5 pi over 6 will be at -2. Pi is back at 0. Then we go up to +2, back down to 0. If I asked for 3 periods, what would you do? Add 4 more points. If you wanted, you could add them this way. Just subtract your pi over 6 to get your negatives. So you could extend it either direction. Okay. This graph has absolutely everything in it that I could give you to complicate your graph at this point. I threw a negative, I changed your amplitude, your period, I had you graph over 2 periods. This is as complicated as they're going to get today. What questions do you have for me? Yes, ma'am.
Do you have to do domain range?
No, I'm not going to ask you on this. No, you could. Domain will always be negative to infinity for these. Your range is just going to be from your amplitude, your negative to your positive. So -2 to +2. Yes, sir.
So I'll do the same for cosine.
We're going to do a cosine here in a second. But the only thing different would be the pattern would have changed. If I had asked you to graph cosine here, cosine always starts at its high point. Since we flipped it, we would have started at -2. And then otherwise it would be identical. Other questions? Let's just keep practicing then. Let's do a cosine one first. What is my amplitude? 3. What else is happening on this one? It's going to flip because I did put a negative in front. Period. To find the period, it's 2 pi divided by the number in front of x, which is pi. So my period is just 2. Then I want the count by, and how do we find that? Period divided by 4 for the 4 quadrants, and you get 1/2. So we're ready to start the graph. My high point would be at +3. My low point is at -3 because of my amplitude. We're starting at our 0 here, and then we're counting by a half. So I have 5 total points, 0 and then the 4 after that. Space them evenly. So the first point, 0 plus 1/2 is 1/2. Plus 1/2 is 1. Plus 1/2 would be 3/2 or 1.5. And plus 1/2 would be 2. Notice that ended where we set our period. So we're in good shape right now. Have I lost anybody? How does cosine start? It typically starts at 1, which in this case would be our amplitude, so 3. But I'm flipping my graph, so it will start at -3. And then we follow the pattern. So then you go to 0, +3, 0, and -3. So the shape isn't changing, just our points. I did ask for 2 periods here. So how many more points do we need? 4 more. We have our starting point already, so we'll tack on 4 more. So 2 plus 1/2 would be 5/2. Plus 1/2 would be 3. Plus 1/2 would be 7/2. Plus 1/2 would be 4. And we continue our pattern. So we're going to go back up, positive, back down. How are you feeling about this so far? I think we could try one on our own. Why don't you guys graph? Y equals cosine 2/3 x. Just do 1 period. Amplitude is the number out in front, which is just 1. Period is always 2 pi divided by the number in front of x. So 2 pi divided by 2/3, which is if you didn't, you probably didn't put your 2/3 in parentheses. But, or you can think of it as flipping and multiplying. So those 2 should drop. Count pi, we do what? Period divided by 4, so just 3 pi over 4. No flipping this time, and we're only doing 1 period, so we just need our 4 points other than 0. So 0 plus 3 pi over 4 would be 3 pi over 4, plus 3 pi over 4, 6 pi over 4, or 3 pi over 2. 9 pi over 4, and 12 pi over 4 is 3 pi. Amplitude is 1, so high and low points are 1 and negative 1. Cosine starts where? At its amplitude, at its high point. Then you hit the x-axis, hit the low point, and you're just bouncing back and forth. High point, x-axis, low point. Questions on that? I'd like to do one more, I think, and then I'm probably stopping. Let's just do 1 period for this one. Times the sine of negative x over 2. Okay, I told you, we talked about that even and odd. And that's so that we don't have to worry about reflecting over the y-axis. Sine is even or odd? Odd. So what does that mean we do if there's a negative? We take it out to the front. If it was cosine, we would just drop the negative and ignore it altogether. So I'm going to rewrite this as a negative 3 times the sine x over 2. I'm going to go ahead and just write that as 1/2 x. So amplitude is 3. Period is 2 pi divided by 1/2, which is 4 pi. Count by is your period divided by 4 for the 4 quadrants, and we get pi. 4's drop. And what else is happening in this graph? We have to flip. Amplitude of 3. Counting by pi, so we've got 0, 1 pi, 2 pi, 3 pi, and 4 pi. Where does sine normally start? At 0. So flipping it doesn't change that. Then it typically goes up, but because we're flipping, it's going down. And then you'll go back up. So it should look like this. Do you guys have questions with anything? What I'd like to do, the only thing I have left in this section is looking at a graph and writing the equation from it, and I think I'm going to do that on, I think we do that assignment, hold on. I think I'm going to do that portion on Monday. I'm going to go ahead and give you the assignment for the whole section. 1 through 12 are just matching questions, so they're going to go pretty quickly. (41) and 45 are the two that we haven't talked about yet. You might be able to do them, but we will look at those two on Monday and then go ahead and start section 2. So this will technically be due on Tuesday, but I would recommend maybe doing everything except the last two. 1 through 12, again, just matching, so there's only 4 that you're actually drawing your own graphs.